Okay, let us start by seeing examples of how we can apply the displacements we have seen. So, the displacement of A is this, and the displacement of B is this. Find the displacement of A relative to B. So from there, they are giving us the displacement of A, R A. They are giving it right as a column vector, 3, -4, 5. Then they are giving us that one for B as 1, -3, 4. Find the displacement of A relative to B. So say A relative to B is going to be A, then minus R of B. It's going to be 3, -4, 5, minus 1, -3, 4. And this is going to be 2, then -4 minus minus, this is -1, then a 1. So this is A relative to B. Then they are asking, this is part A. Then part B, they are asking distance between A and B. So our distance here is going to be the magnitude of A relative to B. So our distance there will be the square root of 2 squared plus -1 squared plus 1 squared, and this will give us roots. This is going to be 4 plus 2, which is 6. They didn't give us units. Units, so we can put just units, as simple as that. Okay, let us come to this. A man started at this and moves at this meters per second, and at the same time, a woman starts from this moving at that. Find the position vector of a man and a woman at any time t. Okay, we have our man here. Our man, first of all, the R at any time, he started from -5, -2. Then his velocity, he was moving at 1, that is his velocity, meters per second. Okay. And the woman, okay, we come to a woman. The woman starts from, so R W naught of the woman where starting from is -2, 1. Then moving at, so the velocity of a woman is going to be moving at 2 meters per second. Find their displacement at any time. For the man, the displacement of a man at any time is going to be his position vector, then plus velocity of the man, then times t. So there our position of the man at any time is going to be starting from -5, -2, then he's moving at 1, 1, then t. Okay, so this will give us, if we get it at once, our RT and the displacement of the man at any time, -5. This will give us -5 plus t, then -2, then plus this, that this we get at t. So that is the displacement of this man at any time t. Then for a woman, okay, I come and I get the one for the woman, displacement of the woman at any time t. Initial position, the velocity of the woman, then times t. This will be -2, 1, then plus. This means the initial position. We are not multiplying by 0, this is the initial position. Then the rest of the woman, 3, 2 times t, which will be the same as -2, 1, then plus, we multiply that, make 3t, then 2t. If we combine, we get -2 plus 3t, then 1 plus 2t. So that is going to be our displacement. It's supposed to be meters at any time. So that was part A. Then part B, displacement of the woman relative to that of the man at any time t. So in part B, they want displacement of the woman relative to that of the man at any time t. We say this is going to be now displacement of the woman at any time t minus displacement of the man at any time t. Now this will be, this one for a woman was negative 2 plus 3t. Then minus that one of a man. Okay, if we simplify this, it will give us, negative, write it here, I'll be having negative 2 plus 3t. This minus to give us positive 5, then minus t. Then this we have 1 plus 2t. This minus to get us positive 2, then minus to get us negative t. So you simplify, negative 2 plus 5, get a 3 plus 3t minus t, get 2t. Then 1 plus this will get 3, then 2t minus that will get plus t. Okay, so this is our of the woman at any time t from that of a man. Okay, then from there they're asking us find the distance between the two after 2 seconds. So we need the displacement after 2 seconds. So, part C, when t is 2, come and substitute there. Our to that of the man between the two. After 2 seconds, we are going to be having 3 plus 2 into 2, then 3 plus 2. And this will give us, this is 4, 7, then 5 meters. Okay, so now our distance is going to be magnitude of this displacement after 2, which would be the square root of 7 squared plus 5 squared. And this will give us, okay, that will be 49 plus 35, 84, very close, 9.1652 meters. So that's the distance when they are. That's the distance between the two after 2 seconds. Now, this question, of course, because they are the starting questions, they have set when the time is given as 2 seconds after this. But now, if they don't give me the time, we are going to see how you get the time yourself. Okay, so that's it. I wish you well.